Located 175 miles west of the Shetland Isles, the Schiehallion FPSO has been producing oil and gas since 1998, when it was installed by BP and its partners to develop the Schiehallion and oil fields after they were discovered in 1993. The vessel has been producing in this harsh environment for over 13 years, and to date has produced and supplied over 300 million barrels of oil. The FPSO is moored in 400 meters of water. It processes over 200,000 barrels of liquid per day. It was installed in 1998 and was engineered with a design life of 20 years. It processes the output from 5 subsea drill centers: West, Central, North, Loyal, and Northwest. The reservoir sits 2,000 meters below the seabed and covers an area of approximately 75 square miles. In 1993, when the fields were discovered, they were thought to hold significantly less recoverable reserves than known today. Since first oil in 1998, the Schiehallion and Loyal reservoir understanding has evolved, and new exploration and breakthroughs in technology have increased the size of the fields. In all, 52 wells were drilled, developing the reservoir with appraisal wells into new areas underneath the existing reservoir. With all the new and existing wells, the project was able to more than double the original recoverable estimate to almost 1 billion barrels of oil and gas. In order to access these increased reserves and to extract the maximum value from the fields, BP and its partners have decided to drill up to 25 new wells and to extend the field life. This huge decision would mean an investment of over $5 billion and a redevelopment of the facilities. The first new facilities required will be new subsea structures. These will include the production trees that will cap the wells. These trees will join the existing subsea drill centers 400 meters underwater, handling produced oil, water, and gas. Across all the subsea facilities, there will be 25 new trees, weighing over 34 tons each. They will join one of the largest subsea systems in the world. Each drill center will have a range of new facilities, including new manifolds to manage the flow from the trees, flowline termination assemblies to act as a valved interface between the flowline and the drill center, and umbilical termination assemblies to distribute the electrical and hydraulic power to the various control systems. New flow lines and umbilicals will be installed to connect the drill centers, in this case from the central drill center. They will carry the oil and gas 3 kilometers back to the FPSO, where they will join pre-installed flowline termination assemblies and the risers to the surface facilities. All 5 drill centers are connected in this way to deliver the extracted reserves from the field to the FPSO, each drill center delivering an increased production from its new facilities. In all, there will be 17 kilometers of new flow lines. At the central drill center, there will be 1 additional manifold, 2 FTAs, and 2 new suds. The West Drill Center will have an additional 9 new wells and trees, which will require 2 new manifolds and a flowline termination assembly. The Northwest Drill Center will have an additional 6 wells and trees and 1 FTA. The Loyal Field Drill Center will also access 5 new wells and trees, requiring 2 new manifolds and changes to umbilical and control distribution and provision of a new flow line. At the North Drill Center, there will be a new well and tree, as well as control and umbilical changes. The output from all 5 drill centers will mean a significant increase in production, and in order to process the reserves for the increased life of the field, BP and its partners took the decision to replace the surface production facilities. In 2014, the fields will be shut down temporarily, and the Schiehallion FPSO will be disconnected from the risers and towed away. In its place, the Quad 204 project will design and fabricate a new FPSO. This huge vessel will be fabricated in modules. The hull will contain tanks to store over 900,000 barrels of oil. The bow of the vessel will house the turret, one of the most complex elements of the FPSO. It will weigh over 10,000 tons and will allow the boat to rotate around the fixed risers. It will be designed and fabricated by Single Buoy Mooring of Monaco. Processing the fluids from the turret is done in the topsides modules. The first modules comprise 2 trains of gas compressors driven by 4 electric motors and capable of compressing 220 million standard cubic feet of gas per day. Separation will be carried out in 2 modules with 4 large separation vessels that together will be capable of separating 130,000 barrels of oil per day. The 2 modules will weigh about 4,500 tons. The 2 utilities modules contain the water injection pumps, amongst a range of other utility equipment. These modules also provide the laydown area for 18 chemical tote tanks. Over on the port side is the power gen module. 4 gas turbine generators will each be capable of supplying a third of the vessel's required 90 megawatts of power. Waste heat recovery units will be fitted to each of the turbine's exhausts to provide heat for the processing stages. The aft end of the vessel is where the accommodation module for 125 people is located. This includes lifeboats and the helideck. Also in this area is the control room, workshops, and vital control and electrical equipment. The vessel will have 2 main cranes that will cover the full length of the topsides. The FPSO will be fabricated and integrated at the world-class facilities of Hyundai Heavy Industries in South Korea. In autumn 2014, the fabricated FPSO will be completed and ready for installation. It'll be towed from the shipyard in Korea to the North Atlantic, a journey that will take 3 months. With a design life of 25 years, this will be the vessel's maiden and only voyage for some time. In order to keep the 250,000-ton vessel in position over the reservoir, it will be secured to the seabed by 20 mooring lines. Almost 2 kilometers in length, the lines comprise chain and wire weighing hundreds of tons each. There will be 21 flexible risers in total connecting the fluids from the subsea system to the FPSO's turret. 15 will replace existing risers, and each riser will be 850 meters long. They will be tethered to an anchor, suction piled to the seabed, giving them enough strength to withstand a 100-year wave, as well as the upward force generated by the midline buoyancy modules. These buoyancy modules give the risers their huge lazy S-shapes, allowing them to create a flexible connection between the seabed and the FPSO on the sea surface. There will also be 6 new additional risers. Together, all the new risers will allow the flow of 320,000 barrels of fluids per day to travel up to the FPSO for processing. This huge engineering and installation task will also allow the latitude required for the Quad 204 FPSO to operate in some of the most inhospitable conditions in the North Atlantic. With waves that regularly reach over 30 meters high, this riser flexibility is vital to ensure the ongoing production from the field. The design of the turret will mean that the vessel will naturally rotate so the bow faces the waves, and the flexibility in the top of the risers allows the vessel to tip and roll in the waves. The lazy S-shapes at the bottom of the risers allow for the FPSO to move backwards and forwards in the swell. This curved arrangement can cope with the vessel moving up to 80 meters in either direction. In early 2016, these facilities will start to allow the fields below to produce at their potential. At peak, it will produce 320,000 barrels of liquid per day, and over its life, more than 500 million barrels of oil. This project represents one of the most complex engineering challenges BP and its partners have ever undertaken. It will set new standards of safe design and quality build, allowing safe and reliable operations of the Schiehallion and Loire fields. The project will supply oil and gas to the UK, Europe, and the world for many years to come.